Hello guys. So today let's try to solve our daily lead code challenge for the day. This challenge is about number complement. In this challenge, we are given an integer number and we have to find its complement. And what do you mean by complement? So the statement itself says the complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zero in its binary representation. So the shaded part says that when you flip all the zeros to ones and all the ones to zeros in its binary representation, you get the complement of an integer. So what do we mean by, so any number has a binary representation, and in that binary representation, when you flip the zeros, when we flip the zeros to ones and ones to zero, then we get the complement of that number. Now, to solve this problem, what we are going to do? So to solve this problem, first of all, we need to find out how many bits are there in a number. To get bits of a number, we will be, dividing the number by 2 repeatedly. And till the time that number becomes 0, that division will continue. And the number of divisions required by 2 is the number of bits in that number. So to do that, thing, we have to take a copy of that number, and then we have to declare one more thing, bit mask is equal to 1. And now what we will do that, we will be dividing that number by 2 repeatedly. And we know that, dividing a number by 2 is same as right shift. Okay, is same as right shift. Okay, and the same number of times by which we are dividing by 2, what we are going to do, we'll be doing, left shift of this bit mask. So we are multiplying by 2. So left shift is same as multiplying by 2. Now, since we have done this, what we will do that, we will decrement that bit mask. So suppose this number is 3 bit, then bit mask will be multiplied by 2 3 times. So bit mask eventually will become 2 to the power 3, that is 8. But we want all bits of the bit mask to be set. So we are decrementing 1. So the property of all the numbers which are just 1 below the 2 to the power 1, 2 to the power 2, 2 to the power 3, all these numbers, the numbers which are just 1 below that number, 1 less than that number, they all have their bits set. So 7 has all its bits set, 3 has all its bits set, and 15 has all its bits set. So we want that number, and with that number, what we are going to do, we are going to do, in order to do complement. Complement means what? If 1 is there, then it should be flipped to 0. And if uh, 0 is there, then it should be flipped to 1. So to do that, we are having a number which, which has all its bits set, and the number itself. So we know that, in the XOR operation, if there is a difference in the bits, then it is 1. So when the given number is 0, then, and we have in our bit mask, then that position bit is 1. So because in bit mask, all bits are 1 only. So if something is 1, then it will become 0, obviously, because XOR 1 and 1, 1 XOR 1 is 0. But if some bit is 0 in the given number num, then since in the bit mask that corresponding position is already 1, so 0 and 1, that will be 1. So we are flipping in that way. So we'll be taking this num and doing this XOR with the bit mask and returning that. That's all. So let's see what's the result. So it's accepting. Perfect. Now you see, there is one more problem, which is saying this question is the same as 100. Let's try this problem as well. Okay. So let's remove this. In this also the same thing is there. So to how to solve this problem? So for this problem, see, the constraint specifies that this number is from 0. And in the previous problem, the number is from, starting is from, the num value can only take values from 1. And here it is taking value from 0. And so we have to, do one thing over here. If n is 0, if n is equal to 0, then we have to return 1. Okay. Okay. If n is equal to 0, then we have to return 1. Okay. And then next thing is, again, we'll be taking the copy of this number. So this time we'll be using the number n, bit mask is already equal to 1. And then same logic what we had used earlier. While num is greater than 0, so what we'll be doing, we'll be dividing it by 2. So dividing is, it means right shift. So we are shifting the bits 1. And every time we are shifting the nums, right shifting the nums value by 1, what we are going to do, we are going to do bit mask is left shifted by 1. So it is getting multiplied by 2, and eventually we'll be getting some power of 2. But to get the bit mask where the all values are, set, what we'll be doing will be, decrementing the bit mask by 1. And decrement is this minus minus operator. And at the end, what we'll be doing, we'll just be doing an XOR bit mask. So what is the property of XOR operation? The property of XOR is that, if at any bit position, the bits are different, then that value is 1. If they are the same, then that bit is set to 0. So in our bit mask, since all bits are 1, and in n, if some bit is 0, then 0 or 1 will be 1. But if some bit is 1 in our number n, then since in the bit mask also, since all bits are 1, the corresponding bit will also be 1 in the bit mask. So 1 or 1 will be 0. And this is how we are flipping it. So this is the property of XOR operation that enables us to flip the digits. And we'll submit this. Perfect. So this is the way to solve this problem. If you have any doubt, please post it in the comments, and I'll be thankful to you. With this, I'll end this meeting. Thanks a lot.